December the 10th, Stochastic Calculus. Class B. And the sun is shining. If you ever had a dream about asking your question, now it's a good moment of time to ask them. So if you have any question about past, then you have. Could we please solve number 7 or number 4? Okay, let's. So the first question is to solve number 7, exam 2008, 2009. So let's first look at this problem. Just a moment. Exam number 7. Okay. So we have a European type claim. Now is time 0. We have time big T. And the European claim pays you at time T maximum of 0 and logarithm of ST. So T is fixed in the contract. And basically our goal is to find X0 in the framework of Black-Scholes model. So here's the problem. Okay, the beginning is very simple to calculate.
But isn't it the same as we solved in the previous class? But instead of st minus k, we have now ln st.
Basically, yes. Basically, yes. All problems are the same. You just use logic and knowledge, and you win. So if you have your questions, you are free to ask your questions. But the question was how to calculate that value. So we take expected value with respect to risk neutral measure of this xt given f0. What do we have basically? Basically, we have, so let's imagine the event A, that st is greater than 1. It's the same that logarithm of st is greater than 0. It's the same event. So in my case, I need to find, so I can take out exponent minus RT because that is non-random quantity. And it is logarithm of ST multiplied by indicator of A given F0. Okay?
Yeah, sure.
Let me even edit. Okay. what is LNST? It is so my main idea that I have two expressions for ST, but I will use the one with starred version of winner process. So it will be R minus sigma squared over 2t times sigma times WT star. The other one is also true, but could we invent an event by Daya? It depends on the goal. In our case, we need to find the price of this X. The payment is ln st or 0 if st is greater than 1 and 0 otherwise. So if your question is just, could you invent an event? Yes, you could. But if you'd like to solve this exercise, we see that it's important to know whether st is greater than 1. So if your question is just abstract, could we invent an event A by ourselves? It depends. To make what? Yes, to make something, yes. But to solve this exercise, my payoff is 0 if st is less than 1. My payoff is positive if st is greater than 1. So to solve this exercise, is important to consider to compare the price of a share with 1. If you are solving another problem, then yes, you may add the events. Okay, so I plug in and I get exponent minus RT. What do I have here? I have indicator of A multiplied by ln S0 plus R minus sigma squared over 2t plus sigma WT given F0. We know that A is can be formulated like ST ln ST is positive, or like ST is greater than 1, or like S0 times exponent of R minus sigma squared over 2t plus sigma WT star is greater than 1, or even like WT star maybe it's better to work with logarithm. Maybe it's better to work with logarithm. I think like this it's better. It would be ln S0 plus R minus sigma squared over 2t plus sigma WT, and it should be greater than 0. Maybe it's better like this. And WT is greater than sigma squared over 2 minus R times t minus ln S0 divided over sigma. And last time we have used scaling to make this random variable WT star has which distribution? Oh, what is it?
Standard normal?
Not standard normal.
Just normal with one.
Just normal, yes, with mean 0 and variance.
T over S?
T.
Yeah, just variance T under probability measure P star. So to make it standard normal, we will divide by square root of T.
Yes.
So WT star divided by square root of T is greater than sigma squared over 2 minus RT minus logarithm S0 divided by sigma square root of t. And let's denote this constant by d. All this right hand side.
Excuse me, why we decided to divide on root of t?
To make it normal 0, 1. Normal 0, 1. Subtract expected value, subtract 0, and divide by square root of variance. The way to obtain standard normal random variable, either I can use tables or I can use standard normal
Thank you.
cumulative distribution function. Okay.
Thanks, great.
Okay, now let's move on. Okay, what do we have now? We have now something like expected exponent minus RT times expected value, indicator that A has happened times ln as 0 plus R minus sigma squared over 2 times T plus sigma WT squared given F0. And my A is formulated now like scale it greater than some number D we have specified. Okay.
Okay.
Now we say that these are known at time 0. This is known at 0. And these two guys are not known at time 0, but they are independent of what we know at time 0. Yeah. Because WT star is just WT star minus W0 star. And increments are independent of what we know. This is future increment. This is future increment with respect to current information. So I can just move ln(0) out of the expected value and remove F0. So it will be exponent minus RT logarithm of S0 plus R minus sigma squared over 2 times T times expected value of indicator of A plus sigma times expected value of indicator of A times WT star. Okay.
Clear.
Any questions? Okay, let's go on. We need to calculate two expected values. So first one, expected value of 1A.
Excuse me, can I interrupt you?
Yes.
Is the 2 or R in the upper brackets?
This
Yes.
is R. R.
Okay, thank you.
We must definitely multiply logarithm of S0 by the
On
expected
expectation.
value.
Yeah.
Yeah, you are right. Okay.
Yes.
Okay, let's calculate every term. Expected value of 1 is just probability of A, is a probability that Wt star is greater than d square root of t. And it's, how can I calculate, how can I express this probability in terms of distribution function?
Define integral.
I will use CDF just
1 minus f.
Yeah. F is standard normal CDF. Or equivalently, I may write like f of minus d square root of t. Yeah. Because
But is it
What?
supposed to be square of t there?
There should be
Square root
only
of
d.
t. Yeah, because we just
yeah,
denoted d already divided by square root of t.
yeah, you're right. We specially made it to make it standard now. Yeah, you're completely right. Boom, 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 boom. This is just to show you have minus d, you have d. This is that part, and that is that part. And they're equal. Okay, the first one we have solved. Let's go to the second one. We need expected value star of 1/8 times sigma w. We have no sigma already. Once again, let's normalize by square root of t. Indicators at a times wt star divided by square root of t. Let's say that wt star over square root of t, let's denote it by z, has standard normal distribution. So it's square root of t times expected value of under p star, yeah, times indicator that is greater than d multiplied by that. And it's square root of t, integral from minus infinity to infinity, indicator that z is greater than d times z times f of z dz, where f of z is standard normal PDF. Okay?
Yeah, clear. This integral is just integral from d to plus infinity z f at z dz, because my function is 0. So if I draw this function, it is 0. Yeah. So basically, from minus infinity to d times, because this indicator is either 1 or 0. 0, 1. Okay, now I think it's we can do this integral, no problem. Oh, I forgot square root of t.
Yes.
square root of t. Integral from d plus infinity z1 over square root of 2 pi and minus 1 over 2 z squared dz. But this integral can easily be computed. I just see that this is the function minus 1 over square root of 2 pi exponent minus 1 over 2z squared from d to plus infinity. If I take the derivative, it will be exactly the same. Yeah. Yes.
Yes.
Yeah, sure.
Okay, if I plug plus infinity, it will be 0. If I plug d, I will get 2. If I plug d, I will get if I plug d, I will get square root of 2 over 2 pi exponent minus d squared over 2. And finally, we just collect every term we have found in a big expression. This is expected value of indicator times w and square root of t 2 pi my exponent minus d squared over 2. What do I need to collect? Expected value of indicator is just f of minus d. And finally, my whole expression is just exponent minus rt. Boop, boop, boop. It's too big, but let's finalize all calculations to make a happy answer. So, okay, let's continue. Continue it. So we need to find x0, and it was exponent minus rt, ln s0 plus r minus sigma squared over 2 times t times, what is the expected value? F
F minus
minus
D.
d plus sigma times square root of t over 2 pi times exponent minus d squared over 2, where d, I don't remember, probably it was something like ln s0 plus r minus sigma squared over 2t. Probably it was like that.
Minus ln.
Minus.
Minus ln. Minus the whole thing. Yeah. Okay, so we have a final answer.
There was square root of t in the denominator, I believe, and
Sorry.
Divide by square root of t.
Where? No.
The whole expression should be divided by square root of t.
Ah, yeah, because we have, yeah, you're right, yeah. I agree.
And should there be should we divide sigma squared over 2? Isn't it just sigma square?
Where?
Нужно.
Where?
Yeah, okay, just my typo. That's okay.
First, second, third line.
Everything is okay.
Can I ask please a question just to ensure? Yes. So if we have just simple function in xt, for example, xt is equal to st squared or something else, so we just plug it in x0 and there will be no such indicators and so on. We just plug in and solve, yes?
Okay.
So we have a formula for x0, then we plug in xt, then we plug in formula for st, and just solve.
Yes, basically, yes, you just compute the expected value. That's the main idea, that in the Black-Scholes model, you can price European claims by just calculating the expected value. There are many other ways to price a claim, but in Black-Scholes model, it's just one expected value and you win.
Okay, thank you.
Okay, I see more questions. Where from do we get sigma, and what does it denote? We have Black-Scholes model, and Black-Scholes model is described by two equations: mu st dt plus sigma w, sigma st dw. And the second one, dbt, is just r bt dt. I have two equations for risky asset and riskless asset. And basically, we have parameters mu, sigma. They describe how the price of a share moves, and R that describes how the price of an obligation of riskless asset moves. Okay, this is just a growth rate, and mu is just growth rate, average growth rate. So if you calculate expected value of ST, you will have exponent of mu t, yeah, bt, sorry, given f0 times f0, yeah, and bt is b0 times exponent rt. And the sigma is just a volatility. What does it mean? If sigma is high, then the price is volatile, the variance is high. You can actually calculate variance in terms of sigma. Sigma, it's not variance, it's volatility. It's like, you may think a little bit like moment, like it's variance per small unit of time, something like that intuitively. But in a rigorous mathematical way, when you will calculate not expected value, but variance of st given f0, then it will be some function that positively depends on sigma. So the meaning of sigma is a volatility, and it describes, we can find how variance of our share price depends on sigma, okay? Stochastic differential equation, solve number 8. Okay, let's see, what is it? Number 8, 18, 19.
Just a moment, I will open the right here. Number 8.
It's stochastic differential equation.
Page 62.
Page 62. Ah,
The very bottom of the page.
Yeah.
okay, let's solve it. Yeah, let's solve it. Why not? dyt is equal to 2yt over t plus 3t to the power of 4 over yt 1 over third dt plus 3t yt 2 over 3 dwt. Y0 is 0. Okay. So we have a hint there. You may use these hints, you may completely ignore them if you solve the problem. So you are graded, no problem. So you may safely ignore them if you, because sometimes the way I solve them at home is not optimal. So maybe there is a faster way. I don't pretend my solution to the stochastic differential equation is the fastest one. So maybe you guess some other substitution or anyway is okay. So it's written you are free to use or not to use the following guiding steps. So
the idea is always to like guess some function form and try to solve it.
Yes, basically with all differential equations, how do you integrate? How do you find any integral in school? Either you have a table of integrals, either you say, oh, we need to guess something to multiply by something. So the same thing is here. It's a little bit like an art. You can easily differentiate using Ito's lemma, but to go from differential equation to original function, it's maybe very hard. Okay, let's use hints. So the point C proposes you that let's check whether yt is a product of something that depends on winner process times something that depends on t only. And let's find dy. In this case, dy would be h prime of t times g of wt times dt plus h of t times g prime of wt times dwt plus 1 over 2 ht g prime prime of wt times dt, because that one is just dwt squared. Okay.
Yes.
So now we have two expressions that should be equal. The original one and the one we have found by Ito's lemma. They should be equal. They should match. Okay, let's match them. What is before dt? What is before dw?
H prime t
Yeah. What is
multiplied.
before dt? So before dt, before dw. So before dt is in the original text 2yt over t plus 3 t to the power 4 over yt 1 over 3. And in my derived expression is h prime of t times g of wt plus h times g prime prime of w divided over 2. Before dw in the original expression, it's like this. In my equation, it's h of t g prime of wt. Yeah?
What we are doing, may you explain please one more time why we are doing like this?
Where our goal is to solve the differential equation. So that's our goal. We have a hint that says, consider not arbitrary solution, but solution of this special form, where one function of w is multiplied by a function of t. And we just use Ito's lemma and obtain expression for dyt. But in the equation, we have expression for dyt. So they should be equal. Okay?
So we chose to consider the original formula only from hint, yes?
So this is original. This is our derivation in the original formula. We have this term before dt, and it should match our formula. Our formula is there. The term before.
I mean, we consider yt is equal j yt multiplied by ht. We get this equation from hint, yes?
Yeah.
How do you know that we must apply Ito's lemma on this expression?
We have no other tools. We have one short sword. Do you know any other how to calculate dyt? Nothing. We know nothing how to calculate dyt. We have only one tool. Basically, we have another one. We have we can do limits. Yeah, we have another opportunity to calculate limits of sums subdividing into small intervals and so on. So basically, if you omit the long tedious calculations of limit in L2, the only tool we have to calculate dyt is Ito's lemma. So we have no other tool, just why do we know them? And we know we have not studied other tools to calculate dyt. Okay.
Next question.
Yeah.
Why did you write t to the
There
power?
is a multiplication by. There is a multiplication by t. Yeah, I agree. Yeah. This is just why. Yeah, I agree. In the original equation, it's multiplied. Okay. Let's move on. Now we need to try to solve. So, okay, maybe it was better to have a uh, So let's look at the second equation because it's much simpler. Let's look at the second equation. Because we clearly see the HT and because HT is non-random and we may guess. So it's not like let's try to guess HT and G prime of W. Okay. Let's guess HT and G prime of first, I would like to change a little bit the power, yeah. We're not sure, Alex, honestly, but it's a guess. So it's not a proof. It's a guess, yeah. We have a guess because so that's why there is additional point E in the hints. So yes, we may have a guess. Let me copy because I will need my equations later. 3TYT. Just I will copy for myself HG prime and 2YT over T plus 3 power 4YT 1 over 3 H prime J plus HJJ over 2. Okay, let's move on. So let us look at the second equation. It looks like 3TYT over 2 power 2 over 3 is H of T times G prime of WT. And it's natural to guess that this part corresponds to H. It's a guess. Why it's a guess? Maybe YT contains T something, yeah? No.
Why maybe? It definitely contains.
Yeah, we can even avoid guesses. Yeah, we may plug in T equal to HT. Yeah, you are right, completely. Yeah, we may plug in Y. Yeah, no guess. 3T times H of T times G of WT to the power 3 over T, H of T, G prime WT. So now we have 3T times H to the power 3 over T. We will say that it's H of T and G of WT to the power 2 over 3. We will call it G prime of WT. Okay.
May you explain one more time, please?
What?
From the part where we decided that YT equals to the multiplication of HT and GVT.
We just plug in. So it's basically, so step 1, step 2, step 3, 4, 5. What is not clear?
Okay, it's fine. Okay, thank you.
Okay, now we have.
So everything that non-random, we just say that it's HT, right?
Yeah, everything non-random, every function. So there can be no T in G.
But still we could have like moved 3 to G.
Yeah, 3, you can put it anywhere. Obviously, if you have a function, yeah, there is a, you have a degree of freedom, yeah? If your function is 6 times T squared times WT power 5, you can decompose it like 2 times T squared times 3 WT So where you put 3, it's arbitrary. It doesn't influence the final answer. Or you may say that is 3 times t squared times 2wt power 5. So
was it just like a guess here, or?
no, it's not a guess. You have a degree of freedom. The answer will not depend. So you have many ways to write h and g, but the final answer will be the same.
Okay.
So, so if you have h and g, you have a degree of freedom where to put constants in h, in g, but if you multiply them, you will receive the same answer. So it doesn't matter really where do you put a constant 3. You may put it in h, you may put it in g. The answer will be exactly the same. The h and g will be different, but the product will be the same, okay?
Okay, thank you.
So I've decided to put it in h because g is something of Brownian motion. It's more complex. So with deterministic function, I'm more comfortable than with stochastic functions. So I prefer to put all objects in deterministic function.
Thank
Okay.
you.
So I have 3t to the power 2 over 3 equals to h to the power 1 over 3 from 4. And basically, h is 27 times t squared. Okay.
Okay.
Now let's use property 5. G to the power 2 over 3 is dg w. So let's write it like this. G is a function temporary. Let's replace for the moment w by some w small, non-random. So yeah, we have g to the power 2 over 3 like dg dw, or we have dg divided by g multiplied by g minus 2 over 3 is just dw. And we can solve because w is just an argument of a function. Now it's non-random. So we have g to the power 1 over 3 is equal to w plus constant. And finally, g of w is equal to w plus c cubed. Or
We need to multiply it by 3. No?
Yeah, you're right, by 3. 27. Yeah, you're right. It's double ut plus c cube over 27. Yeah, I agree. And finally, it's our guess. Why it's a guess? That yt is just 27 times t squared times wt plus c cube over 27 t squared times wt cube plus c. Okay.
Yes.
Now, that's only a guess. Why it's a guess? Because we have completely ignored the first equation. Yeah, we see that the second one is satisfied. We need to check whether the first equation is satisfied. Okay. So basically, it's a guess. We have not proven that it's a final answer because maybe the answer is there are no solutions. Boom. Okay.
Do you mean there are no solutions of this type?
Yeah, exactly.
Boris Borisovich, may I ask a question, please?
Yeah.
Why can you just say that V now is not a stochastic process and take an integral like just of
No, I don't say so. I have replaced. So I'm searching. So that's important. That here I'm speaking about g of small w. This is deterministic function because w is just a variable. Yeah, this is deterministic function.
Yes, but how are we allowed to do so?
Because this should held for every t. This should held for every wt. So if this, so g prime, g is a deterministic function by itself. When you plug in, so basically, what is this? You have a statement where left-hand side and right-hand side are random, but they should be equal for all values of wt, okay? So it's equality.
Yes.
In a sense that for every possible value of wt, they are equal, okay? So for every possible, but wt can be any real number, yeah? So for any real number, they're equal. So I replace this equation by equivalent. I don't say that w is constant. I say, let's replace it by maybe it's better to use another letter, that g of some a to the power 2 over 3 is g prime of a. And now I have completely deterministic equation. So I have replaced, if it holds for every value of Wiener process, then this equation holds for every real number, because Wiener process can take all real values.
Understood. Thank you very much for the explanations.
Okay, now I have a guess and I need to check the first equation. The first equation was, so let's go on the next page. So we need to check first equation. The first equation was, I will copy it here, plus 3 t to the power 4 yt 1 over 3 equals to h prime of t times j w plus h t j prime prime of wt over 2. Okay, and my guess is that it's t t squared
To the power of 2
times wt plus c cube. Okay, so let's plug in here, there, everywhere. 2t times wt plus c cube plus 3
dt.
Would it be t
yeah
sorry, you divided by t.
I should divide by t.
That's why it's okay. Sorry.
It will be t to the power 6 yt plus c cube 1/3. H prime is 2t. This is wt plus c cube plus h. H is t squared plus g prime prime is 6 over wt plus wt plus c, I think, yeah, divided over 2. And I see that everything cancels out, yeah. That's okay. And basically we have a solution. Yt is t squared wt plus c cube. We need to check initial condition. Y at 0 is 0, so it's satisfied. And finally, we got our 15 points. To have more points, we need to calculate expected value and variance. So what is expected value of so let's, I think how it would be faster to solve it. Okay, for expected value, it's more or less easy. Yeah, expected value of yt is expected value of t squared times wt cube plus 3wt squared times c plus 3wt times c squared plus c cube. And it will be t squared times 0 plus 3t times c plus 0 plus c cube. And it is 3t cube times c plus t cube times t squared times c cube. Okay?
Yeah, sure.
With the variance, it's a little bit longer, but let's do it. How we may do the variance faster? Pum, 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 pum. How I may do the variance faster? I don't see. So let's be honest. Let's find the variance. I don't see for the moment how we can find the variance faster than just by applying variance, the general variance formula, just expected value of yt squared minus expected value of yt in brackets squared. I don't see. Maybe there is a faster way. I'm not sure. Okay, that guy, we know it. So let's focus on expected value of yt squared. It will be expected value of t to the power 4 wt plus c to the power 6. And it will be t to the power 4 expected value of wt plus t to the power 6. So let's write Pascal triangle 1, 1, 2, 1, 1, 1 to 1. It's 0 power, first power, second power, 1, 3, 3, 1 power 3, 1, 4, 6, 4, 1 power 4, 1, 5, 10, 10, 5, 1 power 5, and 1, 6, 15, 20, 15, 6, 0. So it will be t to the power 4 expected value of wt to the power 6 plus 6 wt to the power 5 times c plus 15 t4 c squared plus 20 wt cube c cube plus 15 w t squared times c to the power 4 plus 6 wt to the power c times 5, yeah, and plus c times 6. I can omit all odds power, and I will get t to the power 6, expected value of w to the power 6, plus 15c squared expected value to the fourth power of inner process, plus 15 times t times c squared, and plus c to the power 6. Okay, we have almost found the variance. Yeah, any questions?
No, until now, not.
Excuse me, I just joined. I had some internet connection problems. Are we trying to calculate the expected value of the sixth power?
Yes, in particular.
Mm-hmm. Thank you.
Excuse me. Excuse me. Could you hear me?
Yeah, yeah.
Why is it t to the power of 6, not t to the...
Yeah, t to the power 4, sorry. Yeah. Sorry, you are right. We just continue this expression and yeah. Okay, so we need to, but I think we have already calculated. It was, I think, so I think we have 3t squared, yeah?
Yes, yes.
Yes.
And expected value of w to the power 6, I think it's 5 times 3 times t to the power 3, yeah? Like this. Yeah.
Excuse me, are we supposed to prove this property on the exam? Or we can just use it?
I have written that you can use any result from the lecture or classes, provided you state it. So if you write, during classes, we have proven that you are free to state any result and use it. Or you may prove it.
Excuse me.
Yeah.
Are we allowed to have some cheat sheets on the exam or not?
Yes, obviously, because the exam will be online. Obviously, I cannot control for that. I prefer, so it's not possible to control such things. So you are free to use cheat sheet.
Are they allowed
Yeah.
formally?
Yeah. Sorry.
Are they allowed formally?
I allow them. I create exam rules. What is the problem?
Double-sided or one-sided?
I don't care. Double-sided,
Oh,
three-sided,
okay.
six-sided.
So is it just like an open book?
I'm in doubts because when I say open book, then you can because the effort put into the creation of cheat sheet, it's good from methodological viewpoint, so you recover everything. So from one point of view, I have nothing against full freedom, but from the but sometimes it's better to say you should prepare one cheat sheet, and with one cheat sheet you are forced to go through your lectures, to go to like organize material. So I prefer, I think, cheat sheet.
Yeah, that's okay, but there is no limit on the number of sheets you have.
No, I think one cheat sheet is enough. So if you
one cheat sheet, double-sided or one-sided?
Yeah, double-sided. Yeah, I don't care. Double-sided. That's fine.
Thank you.
And our exam will.
If the number of sheets is unlimited, you will just print a lot of books or make a lot of copies. So why bother? So my main idea is that a cheat sheet should help you in writing exam to avoid memorizing long formulas, and it should help you in preparation process, because when you have
Yeah,
one
I
cheat sheet,
agree.
you are forced to like go through lectures to think what is important, what is not important, what you understand, what you end up, and you would prefer to copy. So, and when the number of cheat sheets is unlimited, then you say, oh, I'm too lazy, I will not prepare, I will just print the whole book. And
So
okay.
are we done with this task?
Yes, if you'd like, we can prove this from other viewpoint, but how to prove it?
No, I
What
just
is it?
have a question.
Yes, but we finished. We have calculated where we need to plug in, but I think you can plug in.
No, it considers another task.
Yeah, we have not much time left, but yes, you can.
So assume tau is the stopping time, and it is the first moment when WT, which is the winner process, reaches 100. And we need to find the expected value of the
And it's
exponent.
exercise number. It's which exercise? Maybe
Oh, I don't know. It's from page 41 of your collection. And it's task number 1.
Okay, 41. Yeah. Tau is minimum
stopping
time such that
the absolute
WT
value
is plus minus 100. Okay.
Yeah, and I'm interested definitely in C part, that we need to find the expected value of e to the power of minus 2t.
Okay, yeah. Let's apply some. So we have a hint. Yeah, we have a hint. MT exponent of 2WT minus 2T. Okay. Yeah. You just calculate DMT. You have a hint. So our time is up, but very fast. DMT is just you use Ita's lemma and it happens to be a martingale. Okay, if you just apply Ita's lemma to MT, you will see that it's a martingale. Okay, just a plan. It's a plan of attack. It's not a full solution because I have other classes. So it's a plan of attack. First step is clear. You just calculate DMT and booms, it contains no DT term. Is it clear?
Yes,
or not?
it's clear.
Okay, so it's a martingale. We can apply Dupes theorem. We have discussed that we need not to check technical conditions of the Dupes theorem. So when we apply Dupes theorem, it says that expected value of m tau is expected value of m0, which is obviously 1. Yeah, because if you plug t equal to 0 in MT, you will get 1. Okay.
Yes, right.
So it's exponent of 2 W tau minus 2 tau is is 1. Yeah. Okay.
Yeah, sure.
Okay. Because of the symmetry of my winner process, yeah, it's more or less by the symmetry you can just replace W by minus W. And it's more or less clear that probability that W tau is 100 is the same as probability minus 100, and the probability is 1/2. Okay, just by the symmetry.
Yeah. This
if
is
you
clear.
wait, if you have two borders, you hit one border with probability 1/2 and the second one with probability 1/2 first. Okay, just by the symmetry.
Yes.
Okay, so and if you know the moment tau, it gives you no clues whether the upper border or down border was hit. Yeah.
Yes.
Okay, so they are independent. So you may decompose the product like exponent of 2w tau multiplied by exponent of minus 2 tau is 1.
Mm-hmm.
But this is 100 or minus 100. So this expected value is 1/2 times exponent of 200ths plus 1/2 times exponent of minus 200ths. Expected value of minus 2 tau. Okay.
Okay, now clear. Thanks.
And now you may easily find the
Yeah.
exponent of expected value of exponent minus 2 tau. So that's all for today. Have a nice evening. If you have any more questions, just don't be shy, post them in Telegram chat. I will try to answer them. Okay.
Thank you.
Thank you.
Bye-bye.
Thanks.
Have a nice evening.
Thank you. Goodbye.
Bye. You
Thank you.
too.
Goodbye.